Consider a steam power plant using a reheat cycle as shown in the figure. Steam leaves the boiler and enters the turbine at 4 megapascal, 350 degrees centigrade, where H3 is given 3095 kilojoule per kg. After expansion in the turbine to 400 kilopascal, where the enthalpy is again given 2609 kilojoule per kg, the steam is reheated to 350 degree again, and again H5 is given 3170 kilojoule per kg, and then expanded in a low pressure turbine to the 10 kilopascal, where H6 is given 2165. Okay, all values are directly given. Then what we need to find out? Okay, this is common data question for 2. One is thermal efficiency of the plant neglecting the pump work. Underline that, neglecting pump work. Next one is the enthalpy at the pump discharge. Okay. The second question is very funny question. Why? Because the enthalpy at the pump discharge, always the pump discharge enthalpy is more than the pump entry enthalpy. So only one option is matching, that is option D. We will see that. Okay. So first we will find out the thermal efficiency. See, this is what given. This is what given here. Okay. So first boiler, from the boiler steam is going here to the turbine, and inlet value is given enthalpy, and after expanding for some time, the entire steam, not unlike in the regeneration, not only the small fraction, the entire steam again reheated to the original temperature, that is 350 degrees centigrade in the reheater, and at the exit of the first expansion, the enthalpy is given. At the starting of the first starting of the what is that? Again expansion, the enthalpy is given. Ending of the expansion, enthalpy is given, and then after condenser, enthalpy is given. Okay, all these are given. Then efficiency can be found out very easily. How will you correlate these two? Where is the H3? H3 is before the turbine. So before turbine is this H3 or 3. After that what happened? It expanded up to 0.4. Again it is reheated up to the 0.5. Okay. And again it is expanded up to the 0.6 here. And after that condenser it went up to the 0.1. Okay. And after 0.1, this is the 0.2 pump. After pump, from here to here we are pumping, right? From 2 to 3, okay, 2 to 3, directly 0.3. Okay, in between if you want to take, then you can take this as a 2 dash, and this can be taken as a 3 dash. But anyway, these points are not required here. Okay, and pressure is also given. But no need of a pressure here. Take the pressure. So here efficiency, to find out the efficiency, mu equal to total W and total Q input. Total Q input and total W. By neglecting the pump, we neglected the pump here. Okay. How many W's are there? This is the W1, and here this is the W2. How many Q's are there? This is the Q input 1 from 2 to 3, and again from 3 to 4 again one more Q is right. So this is the Q input 2. Okay. So here if I write W, total W, that is a H3 minus H4, okay, plus another one is H5 to the H6. H5 to the H6, and if I write the Q, one Q is from 2 to 3, so H3 minus H2, okay, another Q is from 4 to 5, so H5 minus H4, okay. All these values are given. Except the H2. H2 is exit of the pump, but pump work is neglected. Then exit of the enthalpy of the pump will become the entry of the enthalpy of the pump here. Okay. By considering like that, efficiency can be calculated here. So mu R equal to, if I substitute these values, okay, So H3, where is H3? H3, see in the examination you no need to draw this, you should be able to identify from this and then calculate. Okay, that only comes with the practice. That is why I have drawn that. So where is the H3? H3 3095 minus H4 is 2609 plus H5 is 3170 minus H6. Where is the H6? This is H6. 2165 whole divided by how much? H3. H3 is 3095 minus H2. This is a H2, but pump, inlet and exit are same here, 29.3. Why same? Because it is mentioned that pump work is neglected. Plus H5. Where is the H5? 3170 minus, where is the H4? This one is H4. 2609. Okay, 2609. So after simplification you will get 41.1 percentage. Okay, this is what you will get. So option is B here. Okay. So coming to the second question, the enthalpy at the pump discharge is, okay, second question. So here I will write the enthalpy at the pump discharge. What are the options? Options are very funny. What is that? 0.33, 0.33, see the units are same, kilojoule per kg, no need to worry about the 0.33, 3.33, C is 4, C is 4 and D is only 33.3. Okay, so here they are asking what is the H2. Obviously, always the H2 should be greater than the H1. Okay, why? Because here we are giving some work W, we are giving the WP. Here what is the WP? WP equal to H2 minus H1 and H2 equal to WP plus H1. So here WP is a positive value here, and we are adding H1. Obviously H2 is always greater than the H1. H2 is the exit value is always greater than the the inlet value, but inlet value is how much? 23.3. so whatever option you choose now, always it should be greater than that. So only one value is greater than the 23.3, that is 33.3. now you might be having one doubt. What is that? In this formula here I have taken 29.3 instead of 33.3. so is there any significant difference? Why? Because if you look at the bit 1, the thermal efficiency given as a 15.8 percentage, B is 41.1 percentage, C is 48.5 percentage, and D is 58. So if you see the option B and C, little bit nearer, not that much, but 7 percentage is there. So even if you substitute this extra 3, like a 33.3, still you will get the 41.1 percentage only. Why? Because compared to the other values, the pump value is very less. Okay, the work given to the pump is very less. Okay, so this is how we need to do in the examination.